Module 2.6, Introduction to the Helmholtz Resonator Lab. In the last module, you learned about Helmholtz resonators. In this lab, you will investigate the effects of changing volume and neck length to see how accurate the Helmholtz resonator formula is. You'll use a vernier caliper, a digital thermometer, a graduated cylinder, a microphone, and an oscilloscope to make the measurements. Turn on the thermometer and place the probe wire somewhere away from your body or any heat source. The temperature reading should appear on the screen. To measure the inside diameter, insert the pointy ends of the caliper into the white tube, expand it to its maximum dimension, pull it out, and take the measurement. To measure the length, put the tube inside the flat ends of the vernier caliper, pull it tight, and take the measurement. The vernier caliper will give measurements of 3 or 4 digits. To read the measurement, we will use the bottom sliding scale and the one above it. The calipers we have read either in millimeters or centimeters. This one is in millimeters. Look for the 0 on the bottom sliding scale. The point on the scale just above it gives you the first 2 digits. In this case, the first 2 digits would be 19 or 19. The third and fourth digits are found by finding the mark on the bottom scale where the lines on the 2 scales line up exactly. In this picture, the lines match up on the 6, which would be the third digit. If it was on the line just to the right of the 6, the last 2 digits would be 6.5. So the reading from this scale would be 19.6 millimeters. You'll measure volume by filling the bottle with water and then measuring the water with a graduated cylinder. We'll hook up a Samson Go mic to the oscilloscope. To open the Go mic, put your thumb in the indentation, press to open the spring, and pull out the silver part. Then check to see that the switch on the side is in the cardioid or heart-shaped position. Connect the USB plug to the Go mic and the 1/8" headphone jack to the Go mic. Connect the other end of the USB cord to the scope, then connect the BNC connector to the scope. It's important to know that the silver side of the mic is the working side of the mic. You should see a small green light if the mic is hooked up correctly and powered up. If you try to record with the black side, you will have poor results. To set up the oscilloscope, press Default Setup. Press the Channel 1 button. Press Probe Setup. Set to 1x, should be blue. Press the multipurpose button. Press Measure. Frequency should be blue. Press the multipurpose button so the yellow box appears. Press the Trigger menu button. Press More. Press Coupling. Scroll to Noise Reject. Press the multipurpose button. Turn the vertical scale knob clockwise to 10 millivolts. Turn the horizontal scale knob counterclockwise to 1 millisecond. You will change these scale settings once you get a waveform. Press the menu On/Off button to turn off the menu. If you need to, turn the vertical scale position knob to center the trace on the screen. Hold the silver side of the mic a few inches away from the neck of the bottle and out of the way of the airstream. Point the airstream across the neck of the empty bottle to get a tone. On the oscilloscope screen, you should see a sine wave. If the waveform is too tall for the screen, turn the vertical scale knob counterclockwise until the waveform fits the screen. While there is a good waveform, press the single button. This should freeze the waveform on the screen. Adjust the scale controls so you can see a tall waveform, 1 or 2 cycles on the screen, and the frequency reading on the bottom left of the screen. Record the frequency into the table. Once you have a good reading, unplug the mic USB plug and plug in a USB flash drive and take a screenshot. Include the screenshot in your lab report. Repeat the entire procedure with the long tube, and then again with the bottle filled 3/4 full with the short tube. Have fun!